Piura is one
of the most influential regions in the production and export of grapes, containing 31 of the total certified hectares of the country and having 3% share in the exports made in Piura during 2018. All this thanks to its climate riches and adequate soil. My college and I choose this project because estimation of grape quality is a current and real problem that affects the region, which we can improve through the implementation of automation technologies. Grape is a fruit rich in phytonutrients and antioxidants. Unlike other products, it must reach certain quality standards for export, which are based on parameters like appearance, color, size, and weight, which we can estimate using machine learning methodologies. That is the reason that this project seeks to use these tools to detect if the export safe color is reached along with an appropriate caliber and weight. To start the project, the data was collected from the Agrícola Saturno group located in the city of Chulucanas, Peru, where around 884 images were taken before the grapes were harvested.
As a second quality parameter that was worked on was the size of the bunch. To achieve this, the contrast of the image was increased. This with the purpose the shadow don't affect the next step. As a second step was used to detect the edges by the method of gradient. Finally, each berry was approximated to a circle by the Hawk transform. As a last step is to multiply this value by a constant that relates to pixel with centimeter. For this we use a node distance in the image. To estimate the bunch weight we work with a multi-layer perceptron network. What we did first was to extract the input parameters to our network. These are cluster area, height, and width of the bounding box. But it's important to normalize this data to have them between an interval and so that there are no problems in the convergence. Then we will have three neurons in the input layers and the number of neurons that have us better results were 6 and 5 neurons in the hidden layer.
The research has been based on working through the technique of transfer learning with two pre-trained models, BGG19 and the ResNet 50. The main idea is to load the weights of the pre-trained architecture with the ImageNet dataset, freezing the weights of the layers except for the last layer, where more open layers will be added, in order to obtain the basic parameters and improve the trained model. Because we work with binary classification, it was not recommended to use the softmax activation function. That is why we have worked with the sigmoid activation function. The optimizer used has been Adam, which is one of the best known and most effective about classification in convolutional neural networks. The second part of the structure of convolutional neural networks is to apply it to an API. In this case, Streamlit, which is a library for creating web applications. In this case, an app has been made from a local server, loading a trained model with the result obtained. Queries needs for the web server in the CNN model trained in H5 format and the code for the graphical interface.
Another technique to classify the web branches is support vector machine. The methodology was composed by 4 steps: segmentation, image preprocessing, feature extraction, and the final classification. The segmentation was done manually in Photoshop due to the complexity of separating the bad grapes from the whole bunch. In the preprocessing, an increase of the image contrast was made in order to highlight the diseased parts of the image and thus make a better feature extraction. Also, we note that an image has many features, but not all are relevant to the training of the model. The best model was obtained with color and texture features. The last step is the classification of the grapes as good and suitable for export or bad and unsuitable. In order to avoid overfitting, the validation of the model was carried out by the current validation with 5 faults.
For the 10 weights estimated in the test, it can be seen that there are good approximations, having an average error of 12.6%, but maximum error of 30% can be appreciated. This can be explained by the fact that only one fault was used. Another causal factor can be that a great number of small clusters were counted than medium clusters.